Hi, I'm Jim Smith with Pan Pipe Productions. Water Treatment in 10 Minutes is a series of training videos for water treatment operators who want to learn new skills, enhance existing skills, and improve plant operations. In this video, I will discuss the key concepts of water disinfection with chlorine. Chlorine has been used to disinfect water for over 100 years. The Jersey City Water Department installed the first chlorination system in 1908. A typical chlorine residual is between 1 milligram per liter, or parts per million, and 3 milligrams per liter, depending on the size of the distribution system and water quality goals for the utility. A chlorine residual of at least 0.2 milligrams per liter is required leaving the water treatment plant, and a chlorine residual is required in 95% of distribution samples. A safe and healthy water supply is critical for any society. Waterborne diseases has been a serious problem throughout the history of man. The concept of water purification goes back many centuries. In 1025, Ibn Sina, a Persian physician, wrote in his book The Canon of Medicine that boiling water made it healthy to drink, and he also wrote about filtering water with linen or wool cloth. Contaminated water can transmit numerous diseases, including cholera, dysentery, hepatitis A, and typhoid. The World Health Organization estimates that over 1 million people die each year from waterborne disease. The majority is children under the age of 5. To prevent these diseases, it is important to properly disinfect the water. Primary disinfection ensures that pathogens, which are disease-causing organisms, are destroyed, inactivated, or removed to prevent infections. With secondary disinfection, the chlorine concentration is managed to ensure pathogens are prohibited from reinfecting the water in the distribution system. Large systems can have thousands of miles of pipeline and have long residence time, or the time between when the water leaves the treatment plant and when it reaches the tap. In some utilities, the residence time can be several weeks. Therefore, it is important to ensure the water continues to be safe. Sometimes additional chlorine is added to the water before it enters the distribution system, and sometimes ammonia is added to create monochloramine. Monochloramine is more stable than free chlorine, so the residual lasts longer in the pipelines of the distribution system. For more information about monochloramine formation, please watch our breakpoint chlorination video. Chlorine is the most common chemical used for disinfection. The two most common chemicals used in water treatment plants are chlorine gas, which is 100% chlorine, and sodium hypochlorite, which is a liquid and typically between 12.5% and 15% available chlorine, which makes it safer to use and transport compared to chlorine gas. Sodium hypochlorite can also be generated on site, but with a lower available chlorine of 0.8%. Calcium hypochlorite is a solid and usually 65% available chlorine, and is used at wastewater plants and in swimming pools. Because it is solid, it is more difficult to control the dose compared to feeding a liquid or a gas. When chlorine gas or sodium hypochlorite is added to the water, the chemistry is the same. For the first equation, chlorine gas, which is Cl2, is added to the water. When chlorine is added to the water, hypochlorous acid, HOCl, and hypochlorite ion, OCl- are formed. The combination of hypochlorous acid and the hypochlorite ion is the free chlorine residual. This reaction is pH dependent, and at a pH of 7.5, the concentration of hypochlorous acid and the hypochlorite ion are equal. As the pH goes below 7.5, hypochlorous acid becomes the dominant compound. Hypochlorous acid is a better disinfectant and is 80 times more effective than the hypochlorite ion for disinfecting E. coli, a common bacteria. Disinfection is influenced by the concentration of the disinfectant, the temperature of the water, and the pH of the water. Chlorine disinfection is typically the last step in the water treatment process. For primary disinfection, the chlorine residual is the amount of hypochlorous acid and hypochlorite ion, or the free chlorine remaining in the water. The chlorine residual is the chlorine dose minus the chlorine demand. The chlorine dose is the amount of chlorine added to the water, and the chlorine demand is the amount of chlorine consumed by impurities in the water, such as organic and inorganic compounds. For example, suspended solids, iron, manganese, and sulfur reacts with chlorine, but does not form a chlorine residual. The chlorine demand of the water changes seasonally as water quality changes throughout the year. The plant operator doses or feeds 3 milligrams per liter of chlorine to the water and has a free chlorine residual of 2 milligrams per liter. What is the chlorine demand? The dose of 3 milligrams per liter minus the chlorine residual of 2 milligrams per liter gives us a chlorine demand of 1 milligram per liter. There are numerous factors that affect how a water utility disinfects the water. These factors can influence both primary and secondary disinfection. The type of organism you want to disinfect is a critical factor. Some pathogens are more resistant to disinfection. Protozoan cysts, such as Giardia and Cryptosporidium, are more resistant to disinfection than viruses, and viruses are more resistant than bacteria. Disinfection decreases as water temperature decreases, since chemical reactions are slower in cold water. Disinfection increases as pH decreases because you have more hypochlorous acid. The turbidity, or the suspended particles in the water, impacts disinfection. The chlorine dose rate increases as the amount of suspended particles in the water increases. The picture on the left shows water that is muddy or turbid. Typically, this water would have a higher chlorine demand than the picture on the right, which is less turbid, and typically would have a lower chlorine demand. The amount of chlorine added to the water and the amount of time the water is in contact with the chlorine is very important. Reactor hydraulics, which is how the water flows through a tank, or how long it takes for the water to go from the inlet of the tank to the outlet of the tank, affects the contact time with chlorine. Water quality factors, such as the amount of organic carbon in the water, or inorganic compounds that contain iron and manganese, or reducing agents such as sulfur, are all important components of chlorine demand and influence disinfection. A critical component of disinfection is CT. C is the concentration in milligrams per liter of the disinfectant residual at the end of the disinfection section, and T is the time in minutes that the disinfectant is in contact with the water from the point of application to the point of residual measurement. CT was developed to ensure Giardia and viruses are inactivated for utilities that treat surface water. The regulations require a minimum of 99.9% or 3 log removal and inactivation of Giardia, and 99.99% or 4 log for viruses. Since Giardia is more difficult to inactivate, treatment plant staff focus on Giardia because if Giardia is inactivated, you will also inactivate viruses. Here's a picture of a 3 million gallon tank of water, also called a clear well. The water in the tank is after filtration and before it enters the distribution system. Chlorine is injected into the water as it enters the clear well, and the time to go across the tank has been calculated by the utility. As the water leaves the clear well, the water is tested to determine the chlorine residual, and the CT for the plant is calculated. When plant staff calculate CT, they divide the removal and inactivation the plant is achieving by the minimum requirement of 3 log to create a ratio. For example, if the plant is achieving 3 log removal, the ratio would be 1, or 3 divided by 3. Every water utility using a surface water source is required to always achieve a CT ratio of 1.0 or higher. If the plant is achieving 6 log removal, the ratio would be 2, or 6 divided by 3. Disinfection compliance is reported to the state as a daily minimum CT ratio. In addition to disinfection, chlorine also has the following benefits. Since chlorine is an oxidizing agent, it helps with taste and odor control and the removal of iron and manganese. Chlorine is also good for ammonia control and improves coagulation of the raw water. And chlorine is helpful in inhibiting biofilms or microorganisms growing on the inside surface of pipes in the distribution system. I hope this video was helpful. Please write your comments below and let us know if you would like us to create a video on a specific subject. If you like the Treatment in 10 Minute series, please subscribe.